Okay, let's look at this question. A volume of 2.5 mole of oxygen at STP, 2.5 mole of oxygen at STP is what? What is the volume of the oxygen? Oxygen is a gas, and when we're talking about mole of a gas, we use the mole concept, the volume mole concept. See, they're asking us the volume, right? And what is the volume mole concept? 1 mole is 22.4 dm cube, is it not? 1 mole is 22.4 dm cube. So you can simply say 1 mole of a gas at STP is 22.4 dm cube. If you now have 2.5 mole, what will be the volume? X. You cross multiply, X is equal to 2.5 times 22.4 dm cube. 2.5 times 22.4 is what? Is 56. Is 56.0 dm cube. So the answer is E. Or you simply say number of mole is volume, given volume, is it not what I told you, over gas molar volume. The gas molar volume is 22.4 dm cube. Number of mole is already given to be 25. Given volume is what we are looking for. Let's call it X over gas molar volume, which is 22.4. You still say that S is 22.4 times 2.5. So, which will still give you 56.0 dm cube. Okay. The next question, what is the molar mass of a substance? If 0.4 mole of the substance has a mass of 25.0 gram, we have options: 62.5 gram, 40 gram, 6.3 gram, and 2.5 gram. So what is the molar mass? Since you are talking about molar mass here, number of mole is mass over molar mass, is it not? You remember that number of mole is mass over molar mass, is it not? So the number of mole is 0.4. Where is the mass? 25 divided by molar mass. So molar mass will be equal to 25 divided by 0.4. Which is equal to 62.5 gram is the molar mass of the substance. So that's very simple. Okay, let's look at this question. How many atoms are present in 6.0 gram of magnesium? The atomic mass of magnesium is 24. Avogadro's number is 6.02 times 10 raised to the power 23 per mole. So you remember that number of mole is still given particle, is it not? I told you, over Avogadro's number. You have to calculate the given particle. Now the number of mole is not given, but the number of atoms is given. The amount of atoms, is given, but the number of mole is not given. So how do you do that? You already know that 1 mole of an atom is 24 gram, is equal to its molar mass. How many moles of an atom will give us 6.0? Is it not? Since 1 mole is 24 gram, which is the atomic mass of the magnesium. So the number of mole of magnesium here is going to be X equal to 6 divided by 24. Is it not? 6 divided by 24 is what? 6 divided by 24 is 0.25. So that is 0.25 moles. 0.25 moles. So what it means is that 0.25 moles, number of mole is 0.25, is equal to given particle which we are looking for over 6.02 times 10 raised to power 23. Is it not? So what's the given particle now? The given particle is 0.25 times 6.02 times 10 raised to power 23. So 0.25 times 6.02 is going to be 1.505, right? Times 10 raised to power 23, which is approximately 1.51 times 10 raised to power 23 particles or atoms. So the answer is C. Okay. Look at this question. The number of hydrogen ions in 4.9 gram of tetraoxo sulfate 6 acid is tetraoxo sulfate 6 acid is right? That is tetraoxo sulfate 6 acid. They're asking you the number of hydrogen ion, steam mole concept, Avogadro's mole concept, where you have that number of mole is what again? Given particle, right? Over the Avogadro's number. But the number of mole is not given. But we know that 1 mole is equal to molar mass of this compound. Is it not? 1 mole is equal to molar mass of this compound, tetraoxo sulfate 6 acid. And what's the molar mass of tetraoxo sulfate 6 acid? Hydrogen is 1. The sum of the atomic masses, or the sum of their molecular masses, 1 times 2 plus sulfur is 32, right? Plus oxygen is 16 times 4. So what do you have now? Total of it is what? 64 plus 32 plus 2, 98, which is equal to 98 gram per mole. So it's 98 gram. So what we have is, if 1 mole is 98 gram, how many mole is present in 4.9? So what do you do now? X is 4.9 divided by 98. Is it not? So what's the number of mole now? 0.05. 0.05 mole. So the number of mole is 0.05 equal to given particle, which we are looking for, the number of hydrogen ion. The number of given particles here is the ions, which we are looking for, over the Avogadro's number, given as 6.02, remember, times 10 raised to power 23. Whether it's given or not, do not forget. So X is 0.05 times 6.02 times 10 raised to power 23, which is equal to what? 0.05 times 6.02 is going to be 0.301. 0.301 times 10 raised to power 23. Do you have that in the option? No. If you take this here, it becomes 3.01 times, we reduce this to 22. So do you have this in the option? Yes, which is A. Okay. If I take it over again, it becomes 30.1 times 10 raised to power 21. I believe you know how to play with your standard form. So that is the answer. Okay, next question. Two cylinders A and B each contain 30 cm cube of oxygen and nitrogen respectively at the same temperature and pressure. If there are 5 moles of nitrogen, then the mass of oxygen is A 3.2 gram, B 6.4 gram, C 80.0 gram, D 16.0 gram. Something is important in this question. If they contain 30 cm cube of, if the volume of oxygen and nitrogen is 30 cm cube at the same temperature and pressure, it implies that they have the same number of moles. Because at standard temperature and pressure, all gases is equal to 22.4 dm cube. So if they have the same volume of 30 cm cube at the same temperature and pressure, they must have, the two gases must have the same number of moles. Is that understood? So if there are 5 moles of nitrogen, it means that the mass, they ask you to calculate the mass of oxygen. It implies that the number of mole of oxygen is also going to be 5 moles because they contain the same number of, the same volume of oxygen, the same volume of gas at the same temperature and pressure. Their volume is 30 cm cube because they have the same equal volume at the same temperature and pressure. They're going to have the same number of moles. So oxygen, the mole of oxygen is 5 moles as well. So number of mole is mass over molar mass. What is the number of mole of oxygen? The number of mole of oxygen is also going to be 5 because it will have the same number of mole with nitrogen. So what is the mass? We are asked to calculate the mass. The mass of oxygen. What is the relative atomic mass of the oxygen? What is the relative atomic mass of the oxygen? Oxygen, or relative molecular mass of the oxygen, is 16 times 2. So 5 is equal to mass over 32. So the mass is going to be the mass is going to be 5 times 32, which is 160 gram. 160 gram. Please, D is 160 gram, not 16.0. Is 160 gram. So D is the answer. Please take note of that. D is 160 gram, not 16.0. So the answer is 160 gram. Is that understood? So you are going to have more calculations on more problems on more concepts. You attempt them and submit in our website. Thank you and God bless you.